All right, guys, so we are going to start off chapter 3 by, the title of this lesson is Solving Quadratic Equations Using Square Roots. Now, remember, the goal of this entire chapter is one thing. We are going to have quadratic functions that look like this. You've got a graph, a coordinate grid, and you've got this quadratic function. When it says solving quadratics, we are interested in these points right here. What it means to solve a quadratic is where does that function, where does it cross the x-axis? Where does it cross? That's the goal. For all of these lessons, this entire chapter, we are looking for those points. Sometimes there's 2 points, and we talked about this in class last time. Sometimes there's only 1 point, like if my parabola just touches in one place. But you also have an option where sometimes the parabola doesn't cross at all. And we're going to deal with those situations as they come up. Today, the method that we're going to use is the square root method. And this is by far the easiest method that we're able to use as long as we are able to use it. It doesn't always work, but when it does, it makes the problems really easy. So one of the first things I want you to pay attention to in the notes is right here, when to use. So this method, we want to use it in 2 different situations. We want to use it if all I have is an x squared. So 3x squared equals 18. There is no x by itself. There is only an x squared. The other time that we want to use it is if there is a square on the outside of the parentheses, but the only x is on the inside. So really, we're looking for 1x, and it either needs to be squared or it needs to be inside the parentheses. We don't want to use it in this example on the right. Notice how there's an x squared and an x in the same problem. This would not be a good method to use to do that one. So I'm going to walk you through a couple of these. The goal here, all you are trying to do is get x by itself. Back in 9th grade, when you would solve linear equations, you would have something like 3x plus 7 equals 5. And you were told to solve that equation. So you would do your railroad tracks and you would get everything away from the x. Your goal would be to get everything on the other side so that x was all by itself, right? Same idea. We want to get x alone. We want to get rid of everything else. So there's an example up here that you can go through on your own. I just want to start going through these examples down here at the bottom. Okay, so example number 1, 3x squared plus 7 equals 55. So I only have x squared. There's no x. So I want to use the square root method. So all I'm going to do is start getting x alone. So I look at my left and the right. First thing I have to do is minus 7 from both sides. And I get 3x squared equals 55 minus 7 is 48. Now I need to get rid of the 3 and the square. I have to get rid of the 3 first. So x squared is equal to 16. I divide both sides by 3. So now I have x squared equals 16, and I need to get rid of the square. Well, the opposite of square is to square root. So the square root cancels out the square, and I get an x. Now, the square root of 16 is 4. If I put that in my calculator, I get a 4. But there are actually 2 square roots of 16, and we haven't used them both very often. But there is a positive 4, and there's also a negative 4. When I take the square root of something, I get 2 answers, a positive and a negative. So the other way that I could write this is x equals positive and negative 4. I can put the plus or minus. Either of these options work. So what that tells me is my parabola is going to cross at negative 4 and positive 4. So it's going to look something like this. Those are the 2 places that I'm going to cross the x-axis. Okay, look at number 2. X squared equals 18. I don't have any x's, I just have x squared. So I'm going to use the square root method, and this one's almost done for me. All I have to do is square root the left, square root the right, and I get x equals positive, negative. Now, if I put square root of 18 in my calculator, I'm going to get an ugly number. That's not a nice, perfect square. So I get plus or minus the square root of 18. Now, if you were to give me this answer, I would probably I might give you some credit, but remember chapter 1, we learned how to reduce these square roots. So 18 is 2 times 9, and 9 is 3 times 3. So what I'm doing, and I'm going to do this the long way since it's been a while, x equals plus or minus, instead of 18, this becomes 2 times 3 times 3. And because it's a regular square root, I'm looking for doubles. And there is one. It's a 3. So that 3 comes on the outside, and the 2 stays on the inside. So I end up with x equals plus and minus 3 root 2, which means x equals a positive 3 root 2, and it also equals a negative 3 root 2. So one thing I see students do quite a bit is when they take this 3 out, they want to put it in front of the plus and the minus. Don't do that. It goes right in front of the square root. It doesn't go in front of the plus or the minus. And don't worry, you're going to get to practice that a whole bunch. So number 3, this one's a lot messier. 3 times x plus 1 squared plus 2 equals 302. Okay, this one doesn't have an x squared. It only has an x that is inside parentheses. So I'm going to use the same method. I'm going to use the square root method. So the first thing I want to do is get x. I want to get everything away from the x. So if I start doing this correctly, and this is something some of you haven't done in a while, to get x alone, the first thing I have to do is minus this 2. So I end up with 3 times x plus 1 squared is equal to 302 minus 2 is 300. Now, the next thing I have to do is divide by 3. So I end up with x plus 1 squared equals 300 divided by 3 is 100. So I'm going to move over here and just rewrite that. X plus 1 squared equals 100. Now, some people want to minus 1. I can't do that because it's on the inside of parentheses. So right now, I have to take the square root to get rid of that square on the outside. So I'm going to take the square root of the left. So that leaves me with x plus 1 equals, when I take the square root of 100, I end up with a plus minus 10. Because the square root of 100 is 10. And I get a positive and a negative 10. I get 2 answers. But unlike the other problems, look over here on the left. I still have a number with my x. It's not alone yet. So now, to get it alone, I have to minus 1 from both sides. So I get x equals a plus minus 10 minus 1. Now, my 2 answers, one of them, the 10 is positive, one of them, the 10 is negative. So if I rewrite this as a positive 10 minus 1 and a negative 10 minus 1, I get my 2 answers. This is a 9, and this one's a negative 11. In my other problems, the numbers were the same, right? They were just positive and negative 4, positive and negative square root 3 root 2. This time, I get a 9 and a negative 11. I get 2 different numbers as my answer. So I would say x equals 9 and negative 11. And you can put it in brackets if you want, as long as I can tell that you are telling me those are the 2 answers. You'll be fine. All right, let's get rid of some of this so that we have some room to work on number 4. X minus 6 squared equals 12. Okay. I have an x, just one x. It's inside parentheses, so I can use the square root method. And the first thing I've got to do is get rid of that square root on the outside of the parentheses. So I end up with x minus 6 equals the positive and negative square root of 12. Now, square root of 12 isn't a nice number. It's ugly. So let's see. First, let's go ahead and try to simplify that because I'm already dealing with it, so let's deal with it. That's 2 times 6, and 6 is 2 times 3. And so I've got 2 2s and a 3. So when I rewrite this problem, x minus 6 equals positive negative square root 2 times 2 times 3. And I'm looking for doubles, and there's a double right there. So those 2's get to move out front. So x minus 6 equals a plus minus 2 on the outside, root 3 on the inside. Okay, what's left? I've got a minus 6 over with my x. I want to get rid of that, so I'm going to add 6 to both sides. So my final answer, x equals a positive and a negative 2 root 3 plus 6. So my other way to write that is x equals a positive 2 root 3 plus 6 and a negative 2 root 3 plus 6. Both of those answers would be accepted. I'll take either one of those, all right? Okay, number 5, 3x squared equals 2x squared minus 49. So all I have are x squareds. There's 2 of them, but I can combine those together. If I minus 2x squared from the left and minus 2x squared from the right, that just becomes 1x squared equals negative 49. Okay, some weird stuff's going to happen. X squared, the 1 just goes away, right? Because it's being multiplied. So now when I take the square root, I'm going to run into a problem. If I square root both sides, I get a positive negative square root of negative 49. And you have been taught that having a negative under a square root is bad. And it is. It causes some problems. What that means in the world of solutions, what I would say, because I have this square root of a negative number, I would say that there are no real solutions. There are solutions, and we'll worry about that in chapter 4. But for right now, when you get a negative under a square root, your answer is that there are no real solutions. Because if I try to put that in my calculator, it's going to say error. There's no number that works. So your answer is either this. You could put this as your answer, just like it is, or you're going to say no real solutions. That's what I would like to see as your answer to number 5. Okay, number 6. I've got an x inside parentheses, so let's go ahead and let's do our square root method. So I'm going to minus 36, and I can already see a problem that's going to come up. 4 times x plus 1 squared equals negative 36. Divide by 4. So x plus 1 squared equals negative 9. And here's my problem, because when I square root the left and I square root the right, I end up with x plus 1 equals a positive negative square root of negative 9. The plus and minus goes in front. But I'm trying to take the square root of a negative. We're not allowed to do that yet. I'll teach you later. But for now, one acceptable answer would be no real solutions. That would be an acceptable answer. You could also minus 1 and get x equals a plus minus square root negative 9 minus 1. You could say that that's the answer right there. But the answer is also that there are no real solutions, because these answers right here, those aren't real numbers. They don't exist. They don't work because we can't take the square root of a negative. That causes issues. So I would put for now that there are no solutions. As soon as you see a square root negative, You go ahead and put that there are no solutions. Now, on practice 3.1, you should have an answer key. And let's look at that really quick before I let you go. Number 7 on the answer key right here. Number 7 has a negative square root. See it right here? So your answer could be negative root negative 1 or root negative 1. You could also use negative I and I, but no real solution is a great answer because there are no real solutions. You don't know how to do that yet. So go ahead and say that there's no real solutions. Number 15 and 17. You might run into a similar problem. You've got negative roots. So you could say there's no real. That doesn't mean don't do the problem. That just means don't panic when you see the answer key and it has numbers as an answer. Those numbers are the solutions. They're just not real. So I will accept this answer, or I'll accept this one. They both work for me.